Hi everyone, I'm Kristina Zoilon and today I'm going to show you how I got my answers from the question. Find the shortest path in graph B using Bellman's fourth algorithm. So the first step you need to do is to initialize the distances, meaning you need to assign the graph A into 0 and the other vertices into infinity. The next step is you need to relax the edges repeatedly v minus 1 times. So for the given graph, distance b equals minimum distance b and distance a plus negative 1. And distance b minus minimum infinity 0 plus negative 1 to distance b minus 1. And distance d equals minimum distance d and distance a plus 3 to distance d equals minimum infinity 0 plus 3 to distance d equals 3. Distance f equals minimum distance f and distance a plus 8 to distance f equals minimum infinity 0 plus 8 to distance f which equals to 8. Distance c equals minimum distance c and distance p plus negative 1 to distance c equals minimum infinity minus 1 plus negative 1 to distance c equals negative 2. So distance d equals minimum distance d and distance b plus 3 to distance d equals minimum 3 negative 1 plus 3 to distance d equals 2. Distance e equals minimum distance e and distance b plus 5 to distance e equals minimum open and close parentheses infinity minus negative 1 plus 5 to distance e equals 4. So for distance g equals minimum distance g and distance d plus negative 1 to distance g equals minimum infinity 2 plus negative 1 to distance g equals 1. So for distance e equals minimum distance e and distance b plus 5 to distance e equals minimum infinity negative 1 plus 5 to distance e equals 4. Distance g equals minimum distance g and distance d plus negative 1 to distance g equals minimum infinity 2 plus negative 1 to distance g equals 1. So distance e equals minimum distance e and distance d plus negative 1 to distance e equals minimum 4 plus 2 plus negative 1 to distance e equals 1. So distance d equals minimum distance d and distance e plus 5 to distance d equals minimum open and close parentheses 2 and 1 plus 5 to distance d equals 2. Distance e equals minimum distance e, distance and distance d plus 5 to distance e equals minimum open and close parentheses 1, 2, and 5 which results to distance e equals 1. Distance g equals minimum distance g and distance e plus 8 to distance g equals minimum open and close parenthesis 1, and 1 plus 8 to distance g equals 1. Distance h equals minimum distance h and distance g plus negative 1 to distance h equals minimum infinity 1 plus negative 1 to distance h, which equals to 0. Then distance I equals minimum distance I and distance h plus negative 1 to distance I equals minimum infinity 0 plus negative 1, which is distance I is equals to negative 1. The next step we are going to do is to check for negative weight cycles. Since there are no negative weight cycles that are present in the given graph, therefore the final shortest distances from vertex A to all other vertices are distance A equals to 0, distance B equals to negative 1, distance C equals to negative 2, distance D equals to positive 2, distance E equals to negative 1, distance F equals to 8, distance G equals to 1, distance H equals to 0, and last but not the least is distance I equals to negative 1. Therefore, the shortest path from vertex A to vertex I is A to B to D to E to G to H and to I, with a total distance of negative 1. So, thank you for watching.